Hi, the following is a summary on how to represent a sine wave in both polar and rectangular form. A sine wave is a curve representing periodic oscillations of constant amplitude as given by a sine function. The general form of a sine wave is a sine omega t plus minus theta, where a is the amplitude of the wave, omega is the angular velocity, t is the period, and theta is the phase difference. This general waveform is useful for graphing and identifying sine waves, but when analyzing AC circuits, we use two different forms to represent the sine wave, which are polar and rectangular form. Polar form represents magnitude and direction, shown respectively by r and the angle theta. To get this, we must convert from general to polar form, simply dividing the amplitude by the square root of 2 and carrying over the phase difference does this. Rectangular form is a complex number as shown, and is obtained by converting the polar form. To do this, we multiply the magnitude in the x and y direction using r cos theta to find x and r sin theta to find y. Given the example 20 sine omega t plus 30, we start off by converting the sine form into polar form. To do this, we must convert the amplitude 20 into the magnitude by dividing it by the square root of 2 in order to get the RMS value, 14.14. The phase difference stays the same and is simply carried over to represent the direction, and just like that, we now represent the sine wave in the polar form 14.14 angle 30 degrees. In order to represent a sine wave in rectangular form, we convert the polar form into the rectangular form by multiplying the magnitude 14.14 by cos 30 to obtain x and sine 30 to obtain y. This gives us the x value 12.12 and the y value 7.07, and by doing this we get the complex number 12.12 plus j 7.07. In order to convert back to polar form, we use Pythagoras' theorem to obtain the magnitude. By square rooting 12.12 squared plus 7.07 squared, we obtain the magnitude of 14.14 once again, and in order to obtain the direction, we use simple trigonometry using the inverse tangent times the y value 7.07 over the x value 12.12. From this we obtain 30 degrees, and that is how you represent sine waves in polar and rectangular form.